So we're now moving on to lesson 6. It's called equivalent resistance. If you recall the gizmo that we were working on, you guys were asked to put couple of resistor in parallel, and then they say remove the battery and put the ohm meters around. Remember, like the little ohm meter that you were putting at the end. And then say if this is 5 ohms and this is 10 and this is 20, what you would realize is that the equivalent resistance, meaning the resistance for all of them together, all of them counting together, you would find that the total resistance when things are connected in series, meaning along the same path, you would realize that you would add them all together and it equals to 25 ohms. And basically what this lesson is going to go through that. Okay, so in most of the circuits, voltage remains the same, like say 120 volt outlet. So only resistance and current can change. So from Ohm's law, V equals to IR, we learned that yesterday. We know that if this is the same, right? Because like your plug, if your outlet at Canada is 120, it's gonna be the same. The only thing that I could change are the resistance. By changing the resistance is either plugging more things in together that would change it, and if resistance goes up, current goes down, or vice versa, right? If you have less resistance, your current will go up. And we have designed these things called the circuit breaker and the fuse, because later on you'll be realizing that when I plug things in parallel, the more things I plugged in, you would realize that the resistance would go down. So the more things I plugged in a parallel, what happened is the total resistance will actually go down. So it's like there's less things to be resisting the flow of the current. Current will eventually get too high, and if it does that, it might even burn down your house. So that's why your house have to have these circuit breaker if there's too many appliances that are plugged in at the same time, because you should know by now that your household is connecting in parallel. So that's why when you turn off one light, the other light would still off, will work. So if too many things goes on, it gets too hot, we have the circuit breaker that will actually stop all the current to let it cool down, so you don't have your burning down of the house, okay? Which is kind of important, right? So we call this equivalent resistance or total resistance. We use the symbol R with a little subscript of T. It's basically the combined resistance for all of the resistors in a circuit. And you already learned this, but I think you guys were having a hard time plugging it in the equation, so we're going to show you today. Okay, if I have resistors that are connected in series, meaning if I have one after another, the total resistance, I just add them all together, so that's easy. Okay, but if I have something that are in parallel, I have this, oh my goodness, humongously big equation. The sum of the inverse equals to each other. And we're going to go through how to do that. Okay, so on the side here, we're just going to go through how to do this very quickly. Okay, if I have a resistor that is 10, and if I have another resistor that is 8, okay, and I say it's plugged in like that. Okay, first thing you need to know is I need to know that this is in parallel. Okay, when I know that this is in parallel, I know that I'm going to use this equation. R, like it'll be 1 over 10. The one is 10 and the other is 8. Okay? Alright, so let's punch this in the calculator together. So when you see something like that, okay, so don't worry about it. I know the 1 over F is like 1 over RT is going to be confusing. But what I want you to focus on is the right-hand side first. Okay, so instead of even using fractions or anything, what I would suggest you to do is honestly punch in the calculator 1 divided by 10, adding 1 divided by 8, and press equal first. Okay, so on my calculator, so I'm going to punch it in 1 divided by 8. I don't even bother with fraction, honestly. Adding 1 divided by 8 equal. Okay, so 1 over RT, I'm going to copy the thing on the left. It's going to be equals to 0.225. So how do I actually find RT? Okay, I need you to find the button that's called inverse on your calculator. Okay, mine is right here. Mine is x to the minus 1. I need you to find the inverse button, which is either x to the minus 1. Sometimes it might be 1 over x. Okay, oops, can you see it? Sometimes it could be that. or sometimes they can be on top of the button, right? Like sometimes they can be these little, like the yellow color thingy that is at the top. You have to find it carefully from your calculator. So mine is right here, x to the minus 1. Okay, if you really don't have it, I will show you another way to do it. If you have the ANS button, we can also do it easily. Okay, so I'm going to do the inverse button first, and then we'll explain the ANS button if you can't find the inverse button. So right now this is in my calculator. So all I do is I press the inverse button and then I press equal. And the answer, I already found the answer for RT to be 4.4. The unit for resistance is ohms. Okay, and then as I said, if you don't have these buttons, okay, what you can also do is use 1 divided by the ANS button if you need to do that. Okay, so let's go through how to do that. So I'm going to start from the beginning. Okay, I'm going to pretend that I don't have these two buttons here. But pretend that my calculator doesn't have that inverse button. Okay, so I'm still going to do this part first. So 1 divided by 10 plus 1 divided by 8 equal. And that's what 1 over RT equals to. So to solve for RT, I would go, after I punch in the first step, I would go 1 divide, see the ANS button at the bottom here. Okay, sometimes it's hidden at the top. If the ANS button is at the top, you have to go shift ANS, right? But mine is right here, so I'm going to go 1 divided by ANS. Can you see what I typed in? And then if I press equal, see how I'm getting the exact same answer when I compare to when I use the inverse button. Okay, so now let's actually move on to real example. Calculate equivalent resistance. Okay, so they first of all recognize the word, big words. Okay, it just means find RT, the total resistance for the entire circuit. Okay, I have two resistors and they are along the same path, so they're in series. So you need to recognize if it's in series or if it's in parallel. So I know that they're in series. So in series is easy because I know that I just need to add them all up. Okay, so you write the equation. So let's just go back to the equation. When things are in series, resistor in series, we just add the resistance together. Okay, so I have 2, so I wrote R1 and R2. R1 is 10, R2 is 15. Total resistance is 25 ohms. Okay, super easy. Okay, now a little bit uglier. Okay, recognize that this is in parallel. I have two resistors in parallel, so I need to write the parallel equation, which is the inverse, right? We have this, so I have R1 and 2 because there is only 2 there. So I have 1 over R1 adding 1 over R2. Okay, challenging you to be able to do this following the math that I was showing you. So 1 over 5 plus 1 over 7. So one of them is 5, one of them is 7. So I need to find RT. So take out your calculator. Remember how we said we're going to work out what is the right hand side equals to. Okay, 1 divided by 5. So take out your calculator, punch this in with me, because if you don't do this with me, you are going to have a hard time on the test to do it on your own. 1 divided by 5, adding 1 divided by 7, press equal. I know the number looks really big. I'm still going to write it out, okay? So 0.342857142. Okay, I'm just going to stop right here. Okay, I'm going to stop right here. Round it to the 6. Okay, I'm not going to punch it in the calculator. I don't need to re-punch it, but I'm going to move on and say what RT is, and you're going to find the inverse button. We talked about the inverse button. Inverse button is either -1 or 1 over x. Find the inverse button. Okay, and so I'm going to press on mine. I'm going to press x to the -1 equal 2.9 ohms. All right, I know I skipped one example. We'll go back to that, but I want to do this one with you first. This one is called a combined resistance. They're not all parallel. They're not all series. You kind of have to break them into different pieces and work on it. Okay, so is this a parallel circuit or is it a series circuit? Hard to say. Okay, one thing I can do for you is if I redraw this picture, maybe it will look a bit more easier to comprehend. R1 is 3. If I draw it like that, it's the same thing. Okay, this is 5 and this is 7. Okay, how are you going to go about and solve this one? Okay, there are steps. Okay, it's almost like we would do the bracket first. I don't know if you've realized, but these two are in series, but then this is then in parallel with the 3. Okay, so the step 1 that you would need to do is you would actually need to work out what the series are first. Okay, so instead of calling it RT, I'm going to do step 1 by finding R23. Okay, so together, the total resistance for resistor 2 and 3 together, I'm going to call that R23. And because these two are connected in series, I can find the total resistance by adding them together. Okay, so I have 5 adding 7, so this is 12. Okay, if I redraw this picture again, basically what I now have is I have a 3 ohms on the left hand side, but on the right hand side, instead of 2 resistors together, they are 12. Do you see now I have 2 things that are in parallel? So now to find the total resistance when they're in parallel, I can now say R2, RT. You can say R123 if you want. It's like we group them all together. Okay, and I'm going to go R1 adding the total resistance of R23. Okay, so 1 over RT, because they're in parallel, I have to do the inverse. It's going to be 1 over 3 adding 1 over 12. See how this is a multiple step question. Okay, now it goes back to the calculator time. I'm going to punch the right hand side on the calculator first. I'm going to go 1 divided by 3. Did I say you need to do this together with me? You need to be able to punch it in your calculator and get the same answer that I'm telling you to make sure you know how to do this, okay? Sorry, 1 over 3 adding 1 divided by 12 equals, so I have 1 over RT equals to 0.417, and then I press the inverse button. So inverse equal, so RT equals to 2.4 ohms. So that's the total answer that we got for this big one. Okay, now this one, what is it? Okay, we got 4 resistors all in parallel to each other. And when things are in parallel, I can say 1 over RT is 1 over R1 adding 1 over R2 adding 1 over R3 adding 1 over R4. Okay, so 1 over RT is, I'm going to plug in the number, so 1 over 20, and then 8, and then 12, and then 17. So you can just do what we did just now, but now add all 4 of the inverses together. Okay, so 1 divide 20, adding 1 divide 8, adding 1 divide 12, adding 1 divide 17. Okay, so I got something like, I'm going to write this out for 0.3172. Did you get something like that? Okay, what's your last step? Find the inverse. Okay, so press the inverse button, and I forgot to mention, if you don't have the inverse button, right, if you don't have the inverse button, so either find this guy or find this guy. If not, you're gonna, whatever answer you have, you're gonna go 1, and then you're gonna press divide, and you're gonna press A and S. So that's the other options, okay, to do the inverse. So I'm just gonna press X to the -1 for myself, and I got the answer for RT to be 3.15. So I'm just gonna write 3.2.